So now that we talked about gravity and simulation iterations, and a little bit about self-collision as well, and floor collision. I mean, you have self-collision that's colliding the cloth together, and then floor collision, which is, let's go ahead and crank up that gravity strength there. Floor collision, which is allowing it to collide with the floor, and collision volumes, which allows it to collide with anything that we choose to, which is whatever we don't have selected and that's visible. And here's another thing too, if you Alt-tap your collision volume, hold down Control and Alt. Let's say, you know what, just unmask this. I'm going to move this to the other side. Oh, we still have brush cloth here, so as I move this over, the collision, this is actually treating it as cloth now, and so it'll actually collide with this object. Let's go to BTR, which is regular transpose. I'm going to move this over here to this side here. Control drag to unmask everything. And now if I do this, and I run the simulation, number one, we have this still selected, so now this is going to run as a simulation, and that's going to result in that falling to the ground. However, if I Alt-tap my plane, and then I run simulation, it's going to kind of ignore it. See how it's still colliding with an invisible ball over here? That's because it still thinks that collision volume exists on that side. What we need to do is we can undo this, and let's just to show that a little bit more. Let's run the simulation. It completely ignores the ball on this side. So what we need to do is recalculate our collision volume, and now when we run it, it'll go ahead and treat that collision volume as if it exists. But what we're going to talk about here is strength and firmness. So again, we've already talked about simulation iterations. Let's go ahead and turn that back down to 100, and then gravity strength, which we can, I guess, keep at 10. Now, what strength is that need for those iteration cycles to maintain the original length relationships of these edges at 100%. Now, the lower you make this, the more it's good the simulation calculations are going to go, hey, you know what? I don't need to maintain those relationships that much. I can let it stretch. Who cares? At 100%, it's going to be like, I need to maintain those relationships. The lower you drop this number, the more it's going to, or the less it's going to care about maintaining those relationships. So if I run the simulation now, it's going to let it stretch and slide all over the surface because it's like, maybe we maintain these relationships, maybe not. If I have it up at 1, you're going to see it does a much better job. And let's turn our gravity strength down. Let's say 5. So we're giving it enough time to calculate, and you're going to say, you can see it kind of, let's maintain these relationships pretty well as it simulates, and then we turn this down to 0.01 and run it. It's just going to go and just allow a lot of stretching. So again, the lower this number is, the more lenient or lax it's going to be about maintaining these edge relationships. If we crank it up, and usually it's set at 1, and I just usually leave it there, that's going to maintain these relationships a lot better. And again, a lot of these go hand in hand. Gravity speed, or the speed at which you use your transposed cloth. Strength, simulation iterations, run how many calculations you're running at a movement. And then also firmness. If we go up here and we have a firmness of 6, and we run that simulation, you're going to see it really wants to keep these edges kind of flat. And resolution also plays a role in this. If we want to have dynamic preview, we have thickness as a preview. You can also go in here to smooth as a preview. It's not real geometry yet. It's still simulating at a lower resolution, but here you can see we're getting a smoother result. But we can also smooth this down to 0. And let's hit Control D or hit divide here. That'll give us more geometry. So now as we run the simulation, it's going to have more geometry to calculate. And you're going to see with that firmness set up at 6, it's almost like a leather. It really wants to keep these things kind of spread out and spaced out. If we drop that to 5, let's go ahead and undo, and then rerun the simulation here. It's starting to droop a little bit, so it's starting to allow these edges to kind of relax. And if we keep dropping this down, like firmness of 4, there we go. Now it's starting to drape even more. Let's go ahead and turn our polyframe back on, so you can see these edges. Firmness of 3. Okay, now it's starting to simulate and kind of relax onto the floor, much more silky. And the lower you drop that firmness, the more it's just going to be just more of a silky kind of drapery until finally you get to firmness of 1. And this is going to be, you're getting a lot more wrinkles. This is almost like a cloth type. Now again, it's kind of being a little more lax with those relationships, though the lower that firmness is, the more it's going to allow that stretching. Strength is fighting against it, but firmness is telling it, go ahead and stretch a little bit, man. So, all of these things are playing together. In fact, I bet if we cranked up our simulation iterations with the firmness of 1, it's still going to be, you know, nice and flowy, but this isn't going to have such a hard time maintaining those relationships. So that's another way where you can get very, let's go ahead and turn on our smooth sub div of 1 a little bit. It'll give you a very nice wrinkly result for that type of cloth, maybe more silky cloth, but it's not going to allow a tremendous amount of stretching. So that's a way to get nice silky wrinkles. If I do a Shift S to store a snapshot, so there's a silky wrinkles, and then we'll undo this, and let's turn our smooth sub div up to 1 so we can get a nice smoother preview. And now we're going to take this firmness up to say 3 and rerun the simulation and let this finish out. There we go. So it's going to go ahead and just simulate down, and now you're going to see the difference. There's firmness of 1 with simulation iterations at 1,000. Here's a firmness level of 3 with simulation iterations at 1,000. We'll do another Shift S, and just for demonstration purposes, let's go up to 5. Run the simulation. You're going to see it's running even slower. You know, it's doing a lot of calculations per movement. And now the cloth is almost sliding off because it's wanting to maintain, you know, kind of that thick leather relationship here. So if I go here now, you're going to see this is firmness of 5.